Hello. My name is Bentley Adkins, and I just wanted to quickly go over this project and the final assignment. And I'll try to make it somewhat quick. So I have three data sets, and this time it's a little bit different. And there wasn't I tried to keep the code pretty short, but it did have to lead to doing a lot of pre-processing anyways. But just to keep it all in one notebook. I thought this was the best thing. So, anyways, this is the final project. We have interactive data visualizations, was the key component, and I decided that my domain was going to be over geographic data because I, one, really enjoyed geographic data, and I think it's the most impactful and one of the coolest types of data visualization have come out over the past decade. A lot of research in GIS and really, really neat stuff involving geographic data. So my first data set, once I went back, this isn't the same data set, but I did decide to use an interactive earthquake map, which the last time I had done this was just a more like a heat to find the magnitude over a region. However, this is more globally. So this essentially is taking data from the past 7 days so that it's almost real time. So the data set's somewhat temporal, but it measures all earthquakes that occur that are over 2.5 magnitude on a 0 to 10 magnitude scale. The code was pretty easy to implement. We have Folium requests and Pandas. Pandas is good for storing in data frames, which is a very, very common library request. You essentially can get data from URLs using this. So we took the data from this URL and stored it as a .json file or just the JSON file. And then Folium was the interactive data visualization tool that I used for this project. So anyways, so that's that part with the data. Pulled the data from the URL. This is actually creating the map, the global map. And let's see, and this is a loop that adds data to the map using the features based off of these nested lists to get the coordinates, the magnitude, and the place, the region. Um, then the issue that we had with this one originally was the fact that Folium requires you to have the data in latitude, longitude, but the JSON data when you pull it is in longitude and latitude. So we ended up needing to swap these two. So this is actually latitude, and this is the longitude coordinate that was pulled from these features. Um, and this is all just part of making these circles on the map for an interactive one. And I stored all of them into HTML. So I'll go ahead and quickly click over here. So this is a zoom in of Cuba here, I believe. And you can click and see you'll have a magnitude of 3.16. The location in compass to and kilometers from a specific location. So then zoom out and then go over here. And we actually had a earthquake happen within the past 7 days with above a 2.5 in Alabama. So, which was 2.53. So that's you might slightly feel that, but it's not super high. The San Andreas Fault and the the plate is over here, so a lot the that one's only a little bit higher. Let's see if I can find one that's a little bit higher. Yeah, 3.69 off the coast, 3.28. So you can kind of see that a lot of the over here on the west coast, there's higher magnitudes of earthquakes occurring. And then I'll move into the next data set, which uses one of my favorite libraries, the Plowly Express, which is very good for creating data visualizations. And then, of course, with Pandas. But this data set is going over the global power plants. So that could be something like hydroelectric power at dams, something like nuclear energy, kind of like TVA, the Sequoia plant. Um, then you have other different kinds of data that you can get through power, coal, gas, nuclear, wind, solar, all a bunch of different kinds. So this was also done in a similar way, but it pulled a has a URL connected to the a GitHub CSV that's from the WRI, which is a public open source place where you can get data. Um, and then let's see. So then you have then next we needed to filter the data. So we were looking at renewable and non-renewable. So then you filter out the data for the primary fuel just to make sure that you're getting these. Which, let's see. And then you have the figure with the scattered map box. And this is actually creating the figure here. So then you have the latitude and longitude data, the colors, the primary fuel. So these different fuels are part of the primary fuel. And then you have the size, which the size, this is the capacity of electricity in milliwatts. And then you have the name of the location of the building. So then we created the hover data that has the country and the capacity in milliwatts for how much power it's generating. And this is the zoom, the height, and then, of course, the title. And then you can create different styles. So, like, if you have something where you're working with different kinds of colors and if you have white and you don't want to use another light color, then you can change the map box. So this one, I had found that using yellow, red, cyan, black, and orange for as a dictionary for notating solar and nuclear was very beneficial for creating a um, a good visualization that has different colors. And then ahead and show you. I can go ahead and show you the HTML map of this. So here we have a bunch of different visualizations here, or a bunch of different plants here. So like we said in our dictionary for notating them, red was nuclear energy as its primary fuel. And then we had solar here, and then we have wind and turbine energy here, then cyan blue. So, and then orange was gas. So, you can zoom out too. Yeah, there's actually a lot here that's being shown. Then black was coal. So yes, this is a very good data set. Let's see. Uh, solar power stations. Mm, sorry, the zoom is blocking my view from being able to click back on this. So then the next one was an OpenStreetMap of UTC using the OSMNX library, which is OpenStreetMatch Network X, which is really good for gathering data for geometry data for buildings and string lines, which are streets. So then you can create a lot of different location visualizations, building something similar to something like Google Maps and then plotting your own data on it. So I imported OpenStreetMap and X, and then GeoPandas is good for converting data into data frames, and it works well with getting data in longitude and latitude, and then converting it into a easier, more formatted uh, data frame. So for whenever you're working with this, the first thing you have to do is get an address as your starting point. So this is the address for UTC because I wanted to do a street map for UTC, and this is the initializing the building. So then we have the address and then the tags if it's a building, true, um, and then the this is the distance, which is equal to a kilometer, which is you can cover quite a lot with that. Um, and then this was the graph from the address. So then this is just identifying the network type here. And then you create your nodes and your streets. It's very similar to the last assignment where we worked with nodes and edges. And then for the ones that were null, that because OpenStreetMap is open source, it doesn't have the name for every building, and they also change quite a lot too. So it can also affect no named buildings. So then we ended up getting a fill in a function here, which is from the GeoPandas or pandas in general. It's also in there too. But every value that didn't have a name, we just put a named building. And this was essentially building it, color, and the name, the disable the hover for the streets using the tooltip, and then we also built a the buildings, and I only wanted to show the name for it because if you show everything, it's a lot of data, and it was too much to read. So then I also stored this one as an HTML. So let me go over and do this. Um, so you can see here some of them were null names, but bigger buildings like this. So this is the McKinsey Arena, the another unnamed, but this is the West Campus housing, bowling apartments, the University Center. I believe this is the ARC. There should be the gym. The library should be right here. Yeah, UTC's library. Dirthig. So it knows a lot of the ones at UTC, which is part of the reason why I picked it too. But whenever you do a kilometer, you actually get a little bit, you can kind of see out a little bit too. Let's see what appears on Market Street. The Edney Building, one of the innovation centers. Um, yeah, so you actually have actually see quite a bit of other buildings, but there's also a lot too that were unnamed because they weren't mapped out. Um, so I think that's going to conclude it for this assignment. Thank you.